So let's take this example. Assume we have three capacitors, a 12 microfarad, a 20 microfarad, and a 30 microfarad connected to a 60 hertz. What is the total capacitive reactance XC when connected in series? So let's see. When they are connected in series, remember that for capacitors to be connected in series, the total or effective capacitance 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So we can work this out as 1 over 12 plus 1 over 20 plus 1 over 30. So what we just have to look for is the LCM of all of this. So that will be equal to, the LCM is 60. 60 divided by 12 is 5 plus 60 divided by 20, that's 3 times 1. We have 3 plus 60 divided by 30, that is 2. 2 times 1, that is 2. So from here you can see that 1 over C is equal to, when we add this together, that's going to give us 10 all over 60, which is equal to okay, so here from here you can see that C is equal to 60 divided by 10, that is 6 microfarad. So that's the combined capacitance in series. But the question is said that what is the total capacitive reactance XC? So we want to look for the capacitive what? Reactance. So to look for the capacitive reactance, we can do this. To look for the capacitive reactance, we can just simply do this. The capacitive reactance SC is equal to 1 all over 2 pi FC. Remember, okay, the frequency is given as 60 hertz, so that will be equal to 1 all over 2 times 3.144 pi times the frequency 60 times 6 microfarad, that's 6 times 10 raised to power minus 6 farad. So I'll work this out. That'll be equal to 1 all over, I'll just work this out from my calculator, 2 times 3.14 times 60 times 6 exponential minus 6. That's equal to 2.2608 times 10 raised to power minus 3. So I'll divide this by 9. So XC by 1 by all of this. XC is equal to 1 divided by whatever I have there, and that is equal to 442.32 ohms. Don't forget that the unit of a reactance is in ohms. Okay, so let's take another example. So I have another example here. A 2 microfarad capacitor. A 2 microfarad capacitor is connected directly across a 150 volt VRMS 60 Hz AC source. Find the RMS value of the current, B, the peak value of the current. So let's get the RMS value of the current. Remember I said that XC is equal to 1 over 2 pi FC. So first of all, let's calculate the capacitive reactance. So to calculate the capacitive reactance, we're going to apply this. So I'm going to have 1 all over 2 times 3.14. That's what I'm using for pi. Times the frequency is 60 hertz. Times C, that's 2 microfarad. That's 2 times 10 raised to power minus 6. So when I work this out, XC is going to be equal to 1 divided by, so I work this out, 2 times 3.14 times 60 times 2 exponential minus 6. That will give me 7.5 536 times 10 raised to power minus 4. So I have 1 divided by 7.536 exponential minus 4. So that's equal to 1,326.96 ohms. Okay, but remember what they asked us to look for is the RMS value and the peak value. So to get the RMS value, remember I said that XC can also be calculated from VRMS all over IRMX. Okay, so we have the voltage given. The voltage is the voltage is given as 150 RMS. So from here you can simply say that IRMS is equals to VRMS all over XC. So we'll calculate this as our voltage is 150. Let's take a look at that, whether that is confirmed. So our voltage is 150 volts, and XC from our calculation is 1,326.96. So our current is going to be 150 divided by 1,326.96. That's equal to 0.113 amp. So that's the VRMS current. Next, we have to look for the peak value of current. So to look for the peak value of current, the formula is simply, so the peak value of current is I naught is equal to root 2 IRMS. So I naught is going to be root 2 times 0.113. So I'm going to work this out. Root 2 times 0.113, that's equal to 0.598. So I'll approximate that to 0.16. 0.16 ampere. So that's the RMS at the peak value of the current.